Hi guys, so in this particular video I want to look at the NBT Maths Exemplar questions, and you'll write this over here, this particular for your university exam entrance in most cases. So let's look at this here. The first question is questions in the section on functions and their graphs will determine whether the test writer understands the properties of a parabola. So let's look at the properties of a parabola. And say question 1 and 2 are examples of this here. So let's look at this first question here, right? It says a function f is defined by y equals to f of x equals to minus x squared plus 6x minus 5. And they're asking us about minimum values and y-intercepts in this particular question. So the options are a minimum y value and a negative y-intercept, a maximum y value and a positive y-intercept, or a minimum y value and a positive y-intercept, a maximum y value and a negative y-intercept. So firstly, by looking at the coefficient of x squared, you can clearly see over here that a is less than 0. Therefore, you're going to have a maximum value. Okay, so maximum value is going to look like that. So if you were to draw this particular graph, it would have this particular shape, right? Maximum value means your maximum y value here. Okay, you'll have a maximum y value. And here you'll have a negative y-intercept because that's your c value in the standard form of the equation of a parabola, which is ax squared plus bx plus c. So c is your y-intercept. So we're going to have a maximum value and a negative y-intercept. A maximum value and a negative y-intercept. The answer will be option D. Alright, so in the next question it says, under the heading algebraic processes, what are the topics listed in algebraic manipulation? Question 2 is an example whether the answer cannot be deduced by substituting into the given options to rule out those that are correct. Okay, so the sum of the roots of the equation. What are roots? The sum of the roots. They want us to add up basically the x-intercepts here. So we need to be able to factorize this quadratic. So we're going to get minus x squared plus 6x minus 5. The first thing that I would do here is I would multiply this by negative 1. So I'll get x squared minus 6x plus 5 equals to 0. And I would now factorize this. Okay, so it's easier for me to factorize x and x. Factors of 5, it's a prime number, so only 1 and 5. Minus and minus. Minus times a minus is plus. Minus x and minus 5x is minus 6x, and x times x is x squared. So always try to check your factorization by multiplication. So x equals to 1 or x equals to 5. So if you add them both up, 1 plus 5 equals to 6. The option is D. Once again, a quick recap. The sum of the roots are x-intercepts. Okay, it's important for us, if you go back to the first question, to know the standard form of a parabola, y equals to ax squared plus bx plus c. But also we can get tested on the turning point form, which is y equals to a into x plus p all squared plus q, or the intercept form, y equals to a into x minus x1, x minus x2. So important to know all your forms. Remember, a is going to be the same in all. If a is positive, you're going to get a minimum value, so your parabola will probably look like that. Okay, minimum y value. Remember, the y value is your minimum or your maximum value. Okay, the sign of a will just tell us whether we are going to have a minimum or maximum value. Okay, now let's look at the next question. So in the next question here, it says another topic listed under the heading algebraic processes is number sense. The following question depends on number sense. The bigger a number, the bigger its square root, as well as the concepts tested in the first two questions above. The expression square root of minus x squared plus 6x minus 5 has a. So once again, concept of maximum value of 2, minimum value of 2, maximum value of 3, and minimum value of 3. So once again, how do we find the maximum or minimum value, which is the y value of our turning point? So it will be as follows. So because it's right, our equation is given in the standard form. There's two ways you can do it. The easier way will be x equals to minus b over 2a, and that would be minus 6 over 2 times minus 1, which is equal to minus 6 over minus 2 is equal to 3. And now substitute that into the original equation. So y will equals to minus 3 squared plus 6 times 3 minus 5, which is equal to minus 9 squared is, oh, I put the minus on the wrong side. So minus will be here. So that will be minus 9 plus 18 minus 5. So we'll have 9 minus 5 is equal to 4. Okay, so let's just substitute. Make sure, right? No calculators allowed in these examinations. So therefore, the square root of 4 will equals to 2. So the answer will be a maximum value because a is firstly negative. That's a coefficient of x squared, right? And when we found the square root of 4, so that gives us 2. So maximum value of 2, that's option A. Okay. The other way we can do this is by completion of the square. So you'll complete the square and write it in the standard form of the completed square, and then this value here will be your maximum value, the Q value. All right. Okay. So if I have time, I'll show you that at the end of this video. Now let's look at this. Question number 4. So question number 4, if the graph of y equals to minus x squared plus 6x minus 5 is reflected in the x-axis, and the resulting graph is then reflected in the y-axis. Okay, so let's have a look at that. The new equation is, all right, so here it's on transformations. So here we're getting tested on transformations. So let's just basically have a look at that. Okay, so transformations. So here, as you can see, so if it's going to be reflected in the x-axis first, which they tell us, so for the x-axis reflection, our rule would be that y will equals to, so for an x-axis reflection, remember that will be x-axis reflection, so the point will go from here to here, right? So what happens? The y value changes, isn't it? So okay, the sign of your y value changes, so therefore the rule would be for the x-axis reflection will be minus f of x. Okay, so let's do that first. So for the x-axis reflection, it will be minus f of x, so we'll get equals 2. So let's change all the signs in this particular function. So it'll be x squared minus 6x plus 5. Okay, and now for a y-axis, the resulting graph is then reflected in the y-axis. So for a y-axis reflection, so let's say now that goes from here, so from a to a primed, and now it's going to go across the side. So it'll be a, let's call it double primed. Okay, so for a y-axis reflection, that's x-axis. So for a y-axis reflection, the rule will be y equals to f of minus x. Okay, because remember now what happens when you reflect in the y-axis, the sign of your x coordinate changes. So that will equals to, so let's look at that. So f of minus x will be minus x all squared minus 6 times minus x plus 5, and that will equals to x squared plus 6x plus 5. So this will be the new equation, x squared plus 6x plus 5. That's option D. Okay, so just remember your rules for transformations. Now remember, transformations can be a reflection, it can be a translation, or it could be a rotation. So generally we're looking at reflections and translations. Okay, so once again the rules, this is the rule for reflection. Minus f of x is a reflection for, right, about the x-axis, and for the y-axis it will be y equals to f of minus x. The next question, one of the categories listed in competent use of logical skills in making deductions and determining the validity of the given assertions. Question 5, which is also example number sense, illustrates what this means. Writers need to assess the various options and make deductions about their validity. Okay, so let's see now whether this statement, so let's read the statement. For any real number x, which one of the following statements is always true? Okay, so let's look at it. Real numbers. So firstly, what are real numbers? Real numbers consist of all the rational and irrational numbers. So all rational numbers are your natural numbers, your whole numbers, and your integers. Okay, and so if you have to look at this, irrational is any non-recurring or non-terminating decimal. Okay, an example of that would be like square root of 2 or pi and so on. Okay, so natural number system, whole number, integer numbers, right? So let's see. So real numbers could be any one of these particular numbers, or it could be any one of these numbers. Okay, so basically it consists of all numbers that we work with. So if, right, by a process of elimination, if I say minus x is less than 0, so that means if I have to substitute a positive value in here, it would be true. But if I have to substitute a negative number in here, okay, it'll be, let's say, minus 1, it will be positive 1. And positive 1 is not less than 0. So this one is out. 1 over x is rational. Now, if x can also, real numbers can also be an irrational number. So if you get 1 over an irrational number, that is going to also be irrational. So that one is wrong. So that's also out. X over x plus 1 is less than 1. Now, remember that integers can also be 0. So it's 0 and positive and negative whole numbers. Okay, so let's now look at a negative number if you put in. So what if you put in minus 1 plus 1? What's going to happen here? You're going to have x over 0, which is undefined. There's no restriction here. So therefore that's out, because you can't have division by 0. So by a process of elimination, D is the correct answer here. 1 over x is greater than 1 if, look at this restriction, x is greater than 0 and less than 1. So if you put any fraction in here, 1 over a fraction will be greater than 1. So D is the correct answer. Okay, so once again, you need to know your theory. Now, let's look at the next question. So in the next question, it says the next two questions are trigonometry category. Question 6 depends on an understanding of compound angles. Question 7 involves the application of trigonometric ratios in a two-dimensional situation. So first you got sine 43 cos 23 minus cos 43 sine 23 is equal to. Okay, so here you need to know your compound angle expansion. So you got sine, cos, cos, sine. So that's your sine expansion. So it'll be sine of basically a minus b, which will be equals to sine of 43 minus 23 degrees, which is equal to sine of 20, right? So that will be sine of 20. So what we have to know is our compound and double angle expansions for this particular question. All right, so compound angle was tested there, right? So go over all your double and compound angle formulas. In this question here, they ask us the following question. Here they say that we got two cell towers. So they tell us here that the angle of elevation of the top of cell tower B from the top of cell tower A is 30 degrees. Okay, so there's your angle of elevation. So the arrow will go that way. The angle of depression of the foot of cell tower B from the top of cell tower A is 60 degrees. So that's your angle of depression. The height of cell tower B is 100 meters. So there's the height there is 100 meters. And the foot of cell tower A and foot of cell tower B are in the same horizontal plane. So same horizontal plane there. The height of the cell tower A is, so they want us to find the height of cell tower A, which is basically that height there. Now, how do we do this? So let's look at this. So first of all, you have right angle triangles. When you have right angle triangles, remember we can use our trig ratios. So TOA. So sine equals to opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, and also you can use the theorem of Pythagoras case in right angle triangles. So if you're given two sides, you can solve for the third side using the theorem of Pythagoras. So let us look what we have here. So firstly, they want this side here. Okay, let's look at what we have. So we've got this one right angle triangle here. But what information do we have? We only got the angle of depression here is 60. So therefore, that will be 60 degrees there. So angle of depression is equal to angle of elevation there. Okay. Next, what do we have here? 60 plus 30. So this here is 90 degrees. So if you look at it carefully, see that angle there is, can you see? 60 plus 30 is equal to 90 degrees. So you've got two right angle triangles. So you've got a right angle triangle also here. Okay. So 60, 30 is 90. You've got that 60. They tell you that this is a 90 degree angle. So that means that's going to be 30 degrees there. And 30, so that will be 60 degrees there, complementary as well. 60, 30, 60, 30 will give you 180. Sum of angles of a triangle equals to 180 degrees. So therefore, what we can do is, we need to choose one reference angle here. Remember that this will be the hypotenuse in this triangle. Okay, so you can choose 30 or 60, it's up to you. Now, this side over here is a common side. If you look at the common side, there's your common side here. So you must include that in your calculation, right? So let's look at that. So if I choose, let's choose 60 as my reference angle. So that will be my opposite side, okay, for this particular triangle. So if I look at this triangle now, so I got 60, I want that, opposite, and hypotenuse. So I'll say sine of 60 is equal to the opposite side, that side opposite, which will give me, or let's just say O, opposite, okay, over the hypotenuse, which is 100. Okay, in fact, let's call it X. Let's call the opposite side X. I think that will be better. O. So let's call this opposite side X. So we'll say X. All right. So therefore, we'll say X will equals to sine of 60 times 100. Now, so you've got X, right? But now let's look at this right angle triangle here. Okay, let's call the side Y. So here you want to find this side, so that will be your opposite side. Okay, and X now is your hypotenuse. So once again, you'll have sine is opposite over hypotenuse. You can say sine of 60 equals to the opposite side, which is Y over X. So Y over X. Right, so as you can see now, what you've got, okay, you've got Y over X there, and if you want now, you can just make X the subject of your equation. Okay, so you've got two equations now, right? So you've got sine 60, so let's make X the subject of our equation again here. So we'll say therefore X is equal to Y over sine of 60. So we've got two equations. Let's call that equation 1 and we'll call that equation 2. So if you look at it now, we can now solve for the unknown side. Okay, so we've got sine of 60, X equals to sine of 60 times 100. So we'll say sine of 60 times 100, right, which will equals to, and this one over here will be Y over sine 60, Y over sine of 60, right? So therefore, Y equals to sine 60 times sine 60 times 100. So we'll have that will equals to sine 60 is root 3 over 2 times root 3 over 2 times 100, Root 3 times root 3 is 3 over 4 times 100, and that should give us 75 meters. And 75 meters will be option D. Okay, so using trigonometry, we can quite easily solve for the height of the tower. So the height of the tower will be 75 meters. Okay. Question 8 combines an understanding of algebraic manipulation, in this case quadratics and spatial awareness. Question 9 tests the understanding of properties of 2 and 3-dimensional objects, as well as surface area. Okay, so let's look at this. So we need to know area, perimeter, surface area, and so on for these particular questions. Okay, so it says suppose ABCD is a square with side length x minus 1 if the area of the rectangle ABFE is x squared plus x minus 2 centimeters. Then the length FC in centimeters is. So we have to know the properties of a square. What do you know about a square? ABCD, all sides are equal, and with a rectangle, opposite sides equal. We know the areas of these figures, hopefully. So let's fill in what we have. So this is x minus 1, x minus 1, x minus 1, and then the side will also be x minus 1. Okay, so therefore the side will also be x minus 1 in this rectangle, and these opposite sides here will be equal. So what's given to us? We are given that the area of the rectangle. So area of the rectangle, remember area is equal to length times breadth. So the area of the rectangle will be x squared plus x minus 2 equals to length times breadth. Now let us formulate. So what do they want us to find? FC. So there's FC there, and there's, so this whole side will be FB. But what is FB equals to? FB will equals to x minus 1 plus FC, which we need to find. And we know that the length of this, or the breadth of this rectangle AB, is x minus 1. So we can now formulate an equation. So we got x squared plus x minus 2 is equal to x minus 1 plus FC, that's our length, so let's put it in brackets, times x minus 1. Okay, let us factorize this. So if you factorize this, you'll get x and x, 2, 1 and 2, so there's a prime number there, so therefore we'll have plus there and minus there. Okay, so that will equals to x minus 1 plus FC times x minus 1. So x minus 1 and x minus 1 cancels. So what are we left with? We are left with x plus 2. Well, we can get rid of the brackets now. We don't need the brackets. Even this bracket can fall away. X minus 1 plus FC. X and x now cancels, therefore FC will equals to 3. Right? Take the minus 1 to the other side. So FC is equal to, and then the length of FC in centimeters is equals to 3. So that's option D. Alright, let's look at the next question. Question 9 is also on spatial awareness, right? And it says the figure represents an empty cube. An empty cube with a circular opening top. The diameter of the opening is half the length of the diagonal AB. The outer surface area of the cube in square centimeters is. Okay, so let's look at this. So cube, what do you know about a cube? Okay, so for a cube, well, we know that number 1, let's just some space here. Okay, so for a cube, we know that in a cube, so what do they want us to find here? They say that the outer surface area of the cube. So the surface area of a cube will be 6s squared. Okay, so all these sides here in a cube are equal to each other. Okay, now what do we have here? They tell us here also that that the opening on the top is circular. Okay, so the area of a circle is equal to pi r squared. The diameter of the opening is half the length of the diagonal. So there's your diagonal, the AB. Remember, square, that's a square, so this is 90-degree angle there. Okay, the vertices of a square is at right angles, so at 90 degrees there. So they tell us that the diagonal, okay, or the opening, let's read that again, the diameter of the opening is half the length of the diagonal of EB. Okay, the outer surface area of the cube in square centimeters. So they want us to find the outer surface area. Okay, and they give us the length of one side, which is A centimeters. Right. So we're gonna now firstly use that. So that's A and A. And now let's use the theorem of Pythagoras to find AB. So AB will equals to, so AB squared, A squared plus A squared, which is 2A squared. So that's AB squared. Therefore, AB equals to the square root of 2A. Therefore, AB equals to the square root of 2 times A. Now we can now write, we know that the diameter of the opening is half the length of the diagonal AB. Okay, so now we can conclude that therefore the diameter D will be half the square root of 2 times A. So therefore the radius will be half times root 2 times A, which is basically going to be root 2A all over 4. So that's now your radius. So now we can work out the area, because remember that the area of a circle is pi r squared. So 6x squared. So the area of this figure will be the area of the cube, which will be 6a squared. So we just substitute a into there. Minus pi r squared will be pi. The radius will be root 2a over 4 all squared, pi r squared, which will leave us with 6a squared minus pi. Root 2 squared will be 2. A squared is a squared over 16, which will be 6a squared. 2 and 16, we can simplify that. 2 goes at 1 time and 2 goes at 8 times, so that will be pi a squared over 8. So minus pi a squared over 8. 6a squared minus pi a squared over 8. So that will be option C. 6a squared minus pi a squared over 8. Okay, so we need to know our formulas for volume and for the total, and for volume and for total surface area of our 2D and 3D figures. Also know your area and perimeter of 2D shapes. The last question. It says here that from the algebraic processes subcategory financial calculations, show what we mean when we say that calculators are unnecessary. An amount of 1,000 Rand is invested at an annual interest rate of 6% interest compounded every 3 months, quarterly. After 5 years, the investment in Rands will be worth. Okay, so what do we have here? P, that amount is invested at an annual interest rate, so that's I, 6%. Interest is compounded every 3 months, so that's quarterly. After 5 years, the investment in Rands will be worth. So N is equal to 5. Okay. Right, so remember that the number of compounding periods M will be 4. So therefore, let's write down the compound interest formula. A equals to P into 1 plus I power N. P is 1,001 plus interest is 6%, so that will be 0.06 over 4. Okay, and 5 years, so the number of payments will be 5 times, remember quarterly payments, so 5 times 4 is 20. Okay, now remember that no calculators are allowed, so we need to simplify this before we give our answer. So this will equals to 1 1000, 1 plus 0.06 over 4, and 20. Okay, so we know that we can eliminate these two answers, so it's between A and C. So basically, if we can do some division here, I'm sure we'll be able to solve this particular question. Okay, so let's look at that. 4 over 4 plus 0.06 over 4, which is equal to 4.06 over 4. 4 into, so we're dividing 4.06, 4 into 4, one time, comma, 4 into 0, so that's 0, and then 4 into 6, 1, the remainder is 2, add a 0, 4 into 25, 1.015, so our answer is A, right? 1.015. Okay, so we managed to do that without the use of a calculator. I hope this helps you in preparation for your NDT examination. I wish you every success, even as you apply to university in completion of your matric year. If you haven't subscribed already, if this video has helped you, please share it and subscribe to my YouTube channel, and also check out all the videos on jrmaths.com. I'll catch you in the next video.